Good morning, students. I welcome you all to the second part of our discussions on force and laws of motion. In the previous class, I had told you about force and its effects. We had studied that force can bring about a change in the state of an object. It can bring an object in rest into motion and can bring an object in motion to rest. It can also bring about a change in the speed and direction of motion of the object, and it can change its shape and size. I'd also given you a little bit of an idea regarding balanced and unbalanced forces. So after studying all these things, now we will proceed with the next part of the chapter and study about the laws of motion. These laws are three in number and were given by Sir Isaac Newton, and that's why they are called Newton's laws of motion. Today, we will be focusing only on the first law of motion. But before we start learning about the law of motion, let me tell you a little bit regarding the life and contribution in the field of science of Sir Isaac Newton. Sir Isaac Newton was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the most influential scientists of all time and as a key figure in the scientific revolution. His book, Philosophiae Naturalis Principia Mathematica, the Mathematical Principles of Natural Philosophy, was first published in 1687, and it laid the foundations of classical mechanics. Newton also made seminal contributions to optics and shares credit with Gottfried Wilhelm Leibniz for developing an important branch of mathematics, that is, calculus. In his book Principia, Sir Isaac Newton has formulated the laws of motion and universal gravitation that formed the dominant scientific viewpoint until it was superseded by the theory of relativity given by Sir Albert Einstein. Newton used his mathematical description of gravity to prove Kepler's laws of planetary motion, account for tides, the trajectories of comets, the precision of the equinoxes, and other phenomena, eradicating doubt about the solar system's heliocentricity. He demonstrated that the motion of objects on Earth and celestial bodies could be accounted for by the same principles. Newton's inference that the Earth is an oblate spheroid was later confirmed by the geodetic measurements of Maupertuis, La Condamine, and others, convincing most European scientists of the superiority of Newtonian mechanics over earlier systems. The laws of motion that were given by Sir Isaac Newton help us to analyze the dynamics of motion, understand why an object can change its state, explain its cause, and understand so many related phenomena. As I told you earlier, that today we will be focusing only on the first law. For that, observe the following pictures. You can see in the first picture, a man is trying to flip a cardboard on which a coin has been placed. What could be the observation? When the cardboard is flipped away, the coin kept over it would fall down. Now, why is it so? Why doesn't the coin move away with the cardboard? Secondly, you can see that a person is on the driver's seat and he is tied with a seat belt. Now, as soon as the car stops, the person moves forward. Why is it so? Even though the car has stopped moving, why does the person continue to be in motion? What is the cause behind it? Let me show you some more examples. Now, a ball is in the state of rest, and as the person is kicking the ball, it comes into motion. Now, is it possible that if this force was not applied, the ball would have changed its state all by itself? Absolutely not. So, what is the property that is resisting its tendency to change its state? Why is an effort required to bring about a change in the state of an object? Now, once the ball comes into motion, will it stop by itself? Obviously not. It will continue moving unless again an effort is made to stop it. Now, you might interrupt at this position and tell me that no, if a ball is rolling on the ground, we do observe that it stops by itself after a while. Is it actually so that no effort has been applied to stop the ball? Or is some force still acting on the ball that is actually bringing a change in its state? What is the property that is helping the ball to continue its state of motion? So, naturally, this question might arise in your mind that will this ball stop all by itself? No. We have to apply a force. And why is this force required to stop the ball? What is the property? And on what factor does this property depend? One more example. As you can see in the picture, there are two buckets that have been hanged with the help of a rope. One bucket is empty while the other bucket has been filled with sand, and you have been given the task to push the buckets. So if a question is asked, which bucket will be more easier to push and which one will be difficult? So obviously, as you can see clearly in the picture, the one which has been filled with sand will be more difficult to be pushed. So why is it so? Obviously, the mass of the bucket containing sand is more. So the tendency or the property that I was talking about, which is opposing any change, resisting any change in the state of the object, is called inertia, and it depends upon mass. So elephant has more inertia than a human because its mass is more than that of a human being. It means it's harder to change an elephant's motion than a human's motion. So inertia is related to mass. Bigger masses have more inertia, smaller masses have less inertia. So you might be wondering how to define this quantity inertia. In simple terms, it is equivalent to laziness, an object's resistance to any motion. Any object, whether it is living or non-living, does not want any change in its state. Like if it is in the state of motion, then it always wants to continue in the same state. And if it is in the state of rest, then again it always wants to continue in the state of rest. It does not want to change its state. This is what is being referred to as a laziness. In whichever state we are, we always want to remain in that state. We don't want to change it. And if any change is to be brought about, then a lot of effort, some force is required. And what should be the magnitude of that force is dependent upon the object's mass. So mass is a measure of inertia. Greater mass is equal to greater inertia, and lesser mass is equal to lesser inertia. So it is easier to stop a bike than a car, and it is easier to move a mouse than an elephant. In order to stop a car, a larger amount of force is required because the mass of the car is more than that of a bike. Similarly, the mass of an elephant is obviously more than that of a mouse, so it will be easier to move a mouse than an elephant. So now we are in a position to define inertia. The property of a body that resists changes in a body's condition of rest or of motion with constant velocity. This is called inertia. The tendency of an object to persist in its state of rest or in uniform motion in a straight line. As I was saying, that the object does not want to change its state. It want to persist, retain its state of rest or of uniform motion. Now when I am talking about uniform motion, I'm also including the direction. So uniform motion in a straight line. So this property, this inherent property of any object to continue in its state of rest or uniform motion in a straight line and oppose any change, resist any change in its state of rest or motion with constant velocity is given the name of inertia. And on what factor does it depend? It depends on mass. More mass means more inertia, less mass means less inertia. So the example that I was giving you earlier, that why that bucket of sand was difficult to be pushed, because its mass is more and its inertia is also more. So as to overcome its inertia, a greater effort has to be applied, a greater force has to be applied. And what type of a force it should be? It should be balanced or unbalanced? It should be unbalanced. So Newton's first law of motion. Newton's first law of motion is often called the law of inertia. This name was given by Galileo. So it states an object at rest will remain at rest, or an object in motion will remain in motion in a straight line at constant speed, unless an external force is applied to it and changes its state of motion. So this external force needs to be an unbalanced one. We have already studied that a balanced force can never bring about a change in the state of the object. So this external force has to be unbalanced. So an object at rest will continue in the state of rest or uniform motion in a straight line unless an external unbalanced force acts on it. This unbalanced force will tend to bring about a change in the state of the object. So from the first law of motion, we are getting the definition of force. Sometimes this question is asked that which law gives you the definition of force. So the first law of motion tells us the definition of force, isn't it? From the law itself, from the statement of the law, you get an idea regarding what is force. You understand that force is the cause which is responsible for bringing about a change in the state of the object, and that is how exactly we had given the definition for force in our previous class. So Newton's first law of motion gives us a definition of force. Now I will be discussing a couple of examples related to the first law. The leaves fall when a tree is shaken. When the branch of a tree is shaken, we see that leaves, flowers, fruits, they fall down. Why is it so? Due to inertia of rest. Now inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. So whenever an object is in the state of rest, it has got inertia of rest. So when a force is applied to bring a change in its state, we want to bring the object into the state of motion, then it resists that change, and that inertia is given the name of inertia of rest. So due to inertia of rest, the leaves try to be in rest. When a tree is shaken, the branch comes into motion, but the leaves try to be in rest. So branch and trunk comes into motion, which causes the leaves to separate from its branch. Hence the leaves fall when a tree is shaken, or the fruits fall down when a tree is shaken. In a similar manner, you can give an explanation to the conditions that when a carpet is beaten with a stick, then dust comes out of it. This is how we clean a carpet, isn't it? Whenever we hit a carpet with a stick, we find dust particles come out of it. Because whenever we hit a carpet, the carpet comes into motion, but the dust remains at rest. Even when we are shaking vigorously a foot mat, dust particles come out. This is exactly the way in which we clean a foot mat in our homes. So whenever we shake it, the foot mat comes into motion, but the dust that is trapped inside it wants to remain at rest. due to inertia, so it gets separated out. Similarly, when you shake a wet cloth, then you find water droplets coming out of it. This is exactly due to the same reason. Next question. This is something that you might all have observed whenever you are traveling in a bus. Like whenever a bus starts, you tend to fall backward. Whenever a bus stops, you tend to fall forward. And whenever a bus takes a sharp turn, you tend to fall outward. The same thing happens with the luggage that is tied on the top of the bus, isn't it? So when the bus starts suddenly, then the lower part of the body starts being in motion because it is in touch of bus, while the upper part of the body tries to be at rest for some time because of inertia. So that is why passengers tend to fall backward when it starts suddenly. Similarly, when a bus stops suddenly, when brakes are applied, we all are in the state of motion, obviously, but as soon as the bus stops, the lower part of the body, which is directly in contact with the bus, stops, but the upper part wants to continue in motion due to inertia, as you can see in the second picture. So that's the reason, even though the bus has stopped, the upper part of the body continues moving forward and we tend to fall in the forward direction. Why is it dangerous to jump out of a moving bus? Now, this is something that should always be followed by every person while traveling in a bus, that they should never try to jump out of the moving vehicle because it is highly dangerous. Why is it so? Many a times we find people trying to catch a running bus or trying to jump out of a moving bus in a hurry. So quite often they fall down and hurt themselves very badly. So in order to avoid this, they should always allow the bus to come to a rest and then they should come down of it. So a man jumping out from a moving bus holds the inertia of motion. Since the bus was moving at a certain speed, so obviously the man was also moving with the same speed. As the man lands on the ground, his feet comes to rest instantly, while the upper part of the body, due to inertia, will continue to move with the same speed as that of the bus. So there is a possibility that the person will fall down. So it is very dangerous to jump out of a moving bus. Why is it advisable to use seat belts? Seat belts always help us whenever the car that we are driving comes to a rest all of a sudden. It prevents us from moving forward with the same speed, as you can see in the picture. So obviously it is reducing the risk of any accident. So seat belts will stop us from moving forward. Suppose the car is moving at a speed of 55 miles per hour and the car accidentally hits another car or any other object. Then if we are not using the seat belts, we will fly forward into the dashboard and hurt ourselves very badly because due to inertia, our body is moving with the same speed as that of the car. And as soon as the car stops, our body will tend to remain in the state of motion. It will not want to come into the state of rest instantly. And as a result, we will move forward. So if we have not used the seat belt, we will hurt ourselves. But if seat belts have been used, then these seat belts will hold us. They will not allow us to move forward, and that will save us from any injury. So it is always advisable for every people who are traveling in a car to use seat belts because they save us from any accident. So these were some questions, some reasoning type questions that we can discuss related to the first law. There are obviously many such situations that can be explained with the help of Newton's first law, and 3 such questions I am giving you as an home assignment. So all of you will try to analyze these situations, that why is it happening, and then you will write down the answer, like why will the coin drop into the glass when a force accelerates the card, Why is it that a slow continuous increase in the downward force breaks the string above the massive ball, but a sudden increase breaks the lower string? And why does the downward motion and sudden stop of the hammer tighten the hammer head? So these three questions you will answer. Try to analyze and answer these questions very simply by making use of Newton's first law, the law of inertia. You can give an answer to all these questions. We will continue our discussions with the second law of motion and related topics in our next class. Thank you.